Welcome to this segment on how to name alkenes. Now that we've covered naming alkanes, along with looking at substituents, now we will take a look at alkenes. Which contain a carbon-carbon double bond. Here they are in their general form. Molecular formula-wise, we're going to take on the formula of whatever the number of carbons is. The number of hydrogens is going to be twice that. Coincidentally, CnH2n is also the general formula not only for alkenes, but for something else that we covered in the last segment on alkanes, which is cycloalkanes. And this is due to the loss of 2 hydrogens from a regular alkane, straight-chained alkane, in order to cyclize the carbons contained in that ring. So, alkenes incorporate a new functionality and thus a new potential site for reactivity, which we'll go into when we talk about the reactivity of alkenes. For now, we're going to go over the basics of how to name alkenes. So we're going to highlight the naming rules established by IUPAC for how to name alkenes. So, number 1. Parent chain contains longest number of carbons with the alkene group receiving the lowest carbon number. So let's take a look at an example. Okay, here is a line angle formula for one particular compound. Now there are 2 ways to number this, either from the double bond at the end, counting 1, 2, 3, 4, 5, or from the other side at the single bond, counting 1, 2, 3, 4, 5. Both directions give me 5 carbons, which is my longest continuous chain. However, we are now going to prioritize the alkene group. The alkene group has priority over the other types of groups that we talked about when discussing how to name alkanes and cycloalkanes. So here the numbering is going to give us the lowest carbon number for the double bond. 1, 2, 3, 4, 5. 5 carbons long is pent. And ordinarily, if it was an alkane, it would be pentane. But here we're going to change the A over to E. So this becomes pentene. Last part is to identify the location of that carbon-carbon double bond because along this 5-carbon chain, it could be at a few different spots. Now, we do not have to necessarily, in this case, put a 1 in front of the pentene, just like with monosubstituted alkanes, in which the substituent is located off of carbon 1. You do not have to place the number 1 in front of something that's called, say, bromobutane. It's implied that the bromine is located on carbon 1 unless otherwise specified with a number greater than 1. So here we can say just pentene. If our double bond was located at a slightly different spot, let's say it was located here, we want to go in again, the direction that gives us the lowest possible carbon number for our 5-carbon chain. If I number from the right, 1, 2, 3, 4, 5. There, that's not going to give us what we're looking for. 3 is the lowest carbon number. But if I change directions from left to right, my lowest possible carbon number for doing the alkene double bond is on carbon 2. So left to right here gives us the lowest possible carbon number. So naming this, also going to be pentene. It's another isomer of pentene. It's just known as 2-pentene. So that's the basics so far. Let's take a look at something a little bit more complicated that involves the next rule.